Hello everyone, welcome to my channel. In this video, we will learn about the error detection mechanism. So first of all, we will see what is meant by an error. So in the communication networks, the data will be transferred from the sender to the receiver. Okay. While transferring the data, so the message sent from the sender must be received in the same manner for the receiver also. So if there is any loss of data or if the transferred message got corrupted in the communication, then it may lead to an error. So whenever the bits flow from one point to another, so they are subject to unpredictable changes because of the interference or noise. Okay, so when the message is passed from one device to another device in the communication network, so due to some unpredictable changes like interference, so the data may lose or the data may get corrupted in the message. So that is called as an error. The change of bits while transferring the data is called as an error. Okay, so there are two types of errors, that is single bit error and burst error. So first one is the single bit error. So the name itself denotes that the term single bit error means that only one bit of a given data unit is changed from 1 to 0 or from 0 to 1. So that means there is only modification of one bit of data in the message. Okay, so a single bit error can happen if we are sending data using parallel transmission. So this kind of errors will occur so when we are using the parallel transmission, when the message is sent using the parallel transmission. So here, so this message, so here the message 0000010. So this message is transferred from sender to receiver. So while transmission, a bit 0 is changed to 1. So at the sender side, the message is in this format, and at the receiver side, the message, so there is a change of one bit of data in the message. So here 0 is changed to 1 at the receiver. So when the message is sent from sender to receiver, the message must be same at both the sender and receiver. But here it is not happening. So there is a change of bit in the message. That is a single bit change. So here 0 is changed to 1 bit. So this is a single bit error. So the next one is the burst error. Burst error means that two or more bits in the data unit have changed from 1 to 0 or from 0 to 1. So in the single bit error, there is a change of only one bit. But in the case of burst error, there is a change of two or more bits while transferring the data from sender to the receiver. So the example of the burst error is given in this figure. So this message is having a burst error of length 5. So this is the message transferred from the sender. So at the receiver side, it is in this format. So there is a change of 5 bits of data. 5 bits of data in the message. So that's why the burst error is of length 5. So here at the sender side, 00100 is modified into 1101. Okay, at the receiver side. So here the burst error is of length 5. So if you observe here, there is not all 5 bits are not changed, but at the length of 5 the bits are changed. So here 0 is converted into 1 and 0 is modified into 1, and the remaining bits are same. Okay, so the burst error doesn't necessarily mean that error occur in consecutive bits. Okay, so the error is not in consecutive bits. So first 2 bits are changed to 1 and the remaining are same, and at the last one, that is 0 is changed to 1. So here the burst error is of length 5. So burst error is most likely to occur in a serial transmission. It most probably occurs in a serial transmission, while the single bit error occurs in a parallel transmission. So next we will see, so what are the different types of the error detection mechanisms. So before going to know about the error detection mechanisms, so we will see what is meant by a redundancy bit. So error detection uses the concept of redundancy bits to check accuracy, which means adding extra bits for detecting error at the destination. So error detection means, so while transferring the data, so if there is any loss of data, so it will be detected that whether the error has occurred or not in the particular message by the receiver. So the receiver will do the error detection here. So it will check whether the sent message and the received message are same or not. So how it will check? So by using the redundancy bits, the sender will add some redundancy bits to the message by performing certain mathematical formulas. So it will obtain some redundancy bits and it will add to the message, and it will transfer the message to the receiver. At the receiver side, the receiver will check so whether there is any error in the message or not by using the same redundancy bits. So redundancy bits means it is the extra bits added for error detection at the destination side, at the receiver side. So redundancy bits means the extra bits which are added to the message to know whether there is any error in the message. So there are three types of redundancy checks, that is error detection methods. The first one is parity check. So again the parity check is divided into two types, that is VRC and LRC. And the second one is the cyclic redundancy check, CRC, and the third one is checksum. So these are the three types of the error detection mechanisms. So first we'll look after the parity check. The most common and least expensive mechanism for error detection is parity check. Okay, simple parity check or vertical redundancy check. So parity check is again divided into two types, that is a simple VRC and LRC. So first one is a VRC, that is a vertical redundancy check or simple parity check. A redundant bit called a parity bit is added to every data unit so that the total number of ones in the unit including the parity bit becomes even or odd. So here the parity bit means an extra bit that we are adding to the message. Suppose we are adding a parity bit that is 1. So if we add the parity bit 1 to the message, then if it is even parity means, so the number of ones in the case of even parity, so the number of ones in the given message must be even. Suppose if the message follows the odd parity, then the number of ones in the given message must be in the odd format. Okay, so let us see that with an example here. Simple parity check. So at the sender side and receiver side. So at the sender side, we are sending a message 114001. So here we are using a concept called even parity concept. Okay, so in the even parity concept, the number of ones in the given message must be even. Okay, so if it is not even, then we have to add one extra bit, that is a parity or redundant bit, such that the given message, the number of ones in the given message will be in the even parity format. So here there are 3 ones in the given message. So we have to add one redundant bit, that is 1 to the given message, such that it follows the even parity concept. Suppose if the same message is following the odd parity concept, then we should not add anything. Right? We have to add only a 0 to the given message if you are following the odd parity concept. But here the VRC we are following the even parity concept. So that's why we are adding one extra bit to the given message, such that all the ones will become even. Right? So for the given data, we are calculating the parity bit, that is the even parity concept. So by using the even parity concept, we have to add only one redundant bit for the message at the sender side, and this message is allowed to transfer through the transmission media to the receiver node. So at the receiver node, so it will consider the given message and it will discard. It will check whether there is any detection or error in the given message or not. So if there is any error, then it will count the bits and it will remove the, it will perform the error detection method, that is the even parity for the given message. So if the given message is in the format of even, then drop the parity bit and accept the data. Okay, so if it is not even, then there is an error in the given message. So this is the simple parity check or VRC. So this is an example. Suppose the sender wants to send the word world in the ASCII 5 characters are coded as. So this is the ASCII code for the given word W. So 111011, and for the O 1110 4 ones, and for the R 1110 010, and L and D. Okay, so we need to add a even parity bit for the given message. So here for the W, the ASCII characters will be in the 7 character format, right? So here the 7 characters are there. We are adding one redundant bit for the given message. So here the number of ones are even. So we need to add one 0 bit for the given message to follow the even parity. Similarly here, the number of ones are in the even format. So that's why we need to add an 0 bit as a redundant bit for the O. And for the R also the number of ones are even. So we need to add 0 as a redundant bit. And for L also, number of ones are even. So we need to add a 0. And here for D, the number of ones are odd. So we need to add 1 bit to make the number of ones even. Okay, so in this manner we are following the even parity concept to transfer the word world through the transmission media. So next one is the two-dimensional parity check or LRC. So we know that parity check is divided into two types, VRC and LRC. So we have seen the VRC here, and we will see the LRC, that is a longitudinal redundancy check. So in this type of check, we are performing the parity operation in the two-dimensional format. So in the VRC, we have seen only single dimension parity. That means, so in only one dimension for every word we are applying the redundancy bit. But in the case of LRC, so we are applying the two-dimensional parity. That means at 2 dimensions we are applying the even parity concept, and we are adding a redundant bit here. So this is the original data that we want to transfer through the transmission media. Okay, so we are writing all the messages here. So first one 11100011, and then 101101. Okay, and all this data here. So now we are applying the two-dimensional parity check here. So we are we are applying the redundancy bits at a two-dimensional format here. Okay, so first one, so we are going to check the we are going to know the parity for the messages in the horizontal manner. So first one is so 1 1. So we are having the even number of ones in the given message. So that's why, so we are having odd number of ones in the given message. So that's why we are adding a 1 bit, so such that it will become a even parity. Okay. So similarly here also we are having a 5 number of ones. So we'll add 1 bit to make it it follows the even parity concept. So next here also, so total number of ones are 4. So we have to add 0 because it is already in the even parity format. So last one 1 1. So we are having 3 ones here. So we need to add one bit to make it even parity, right? So horizontally we have performed the parities. We have found the parities. So now vertically we will perform the parity check. Okay. So here vertically, so we are having 2 bits. So it is already in even format, so we'll add 0. And here also we are having 3 ones. Okay, so we'll add 1 extra bit, okay, for the even parity. And here also we are having 2 bits, 2 1 bits, right? So we won't add any extra 1 bit, so we will add 0 here. And here there are 3 1 bits, so we'll add 1 bit to make it 4, that is to follow the even parity concept. So here it is already in even parity, so we will add a 0 here. And here there is only 1, so we need to add 1 extra bit to make it even parity. So here there are 4 ones, that means it is already in even format, so we'll add a 0 here. Okay, so now we will write the column parities at the end of the message, at the given original data. So we are adding the column parities at the end of the message, and we will transmit this message to the receiver. Okay, so this is the 2-dimensional parity check. So using the 2-dimensional parity check, suppose the following block is sent. Okay, so this message we are sending. So hit by a burst noise and some bits are corrupted. Okay, that means, so burst noise means there is more than 2 bits of error, 2 bits of messages got changed here. Okay, so that means, so 001 1001 is converted to 0011, and so 041s are converted to 1000. So in this manner, so there is a burst noise of error here. So when the receiver checks the parity bits, some of the bits don't follow the even parity rule and whole block is discarded because some of the blocks are not following the even parity rule. So 2-dimensional parity check increases the likelihood of detecting burst error. A burst error of more than n bit is also detected by this method. So next one is the cyclic redundancy check. So this is the most powerful of the redundancy checking technique. So CRC is based on the binary division. So here at the sender side and receiver side, so we will see how the redundancy bits are calculated for the particular message. So sender has a generator polynomial g of x, and sender will append n-1 number of 0 bits to the data. Okay, so it will add n-1 number of 0 bits to the end of the data. So it will divide the appended data with generator g of x using modulo 2 division. So here we are performing the modulo 2 means XOR operation. So remainder of the n-1 bits will be the CRC. So this will be done at the sender side. And at receiver side, so receiver has some generator polynomial g of x. Receiver divides the data plus CRC with the generator polynomial, and if the remainder is 0, data is correctly received, else rejected. So here the sender will transfer the data and it will perform the XOR operation of the divisor, and the remainder will be added to the given data as the redundant bit, and it will be transferred to the receiver. At the receiver side, so it will perform the XOR operation of the given data, that is the combined data of the message, the original message and the CRC, and it will perform the XOR operation on the given message. So if the remainder is 0, then it will be accepted, else it will be rejected. So now let us see how can we perform the CRC for the given data. So this is the divisor and the dividend. So the divisor is given in the format of generator polynomial g of x. Okay, so the sender will append n-1 number of bits to the data, that is the dividend. So dividend is the data and divisor is in the format of generator polynomial. So we need to convert the divisor which is in the generator polynomial format into a binary format. Okay, so here, so it is given, we know that a power 0 equals to 1. So similarly here x power 0 is equals to 1. Okay, and x power 1 is not given here, so it is not mentioned here. Okay, so that's why it is a 0. And x square, so it is given, x square is given, x cube is given, so we need to write here. So 1, that is x cube is given, x square, and x power 1 is not mentioned here, that's why we are taking it as 0, and x power 0 is 1. Okay, so first step is finished here. So we are converting the generator polynomial into binary format. And the second step is the sender will append n minus 1 number of 0 bits to the data. So n is the divisor and n minus 1, that is 4 minus 1 is 3 number of zeros will be appended at the end of the data. That is the for the message dividend, the dividend message. Okay, and divide the appended data with the generator g of x using the mod 2 division. So 2 steps are done here. So we need to add 3 extra bits 0 for this dividend, that is n minus 1. So now we will perform the XOR operation here. So 1 1 0 1 followed by 1 0 0 1 and 0 0. So we are adding the 3 extra bits 1 2 and 3. So now we will perform the XOR operation here. Okay, 1 for 1 1 0 1. So it will give so if the 2 bits are same, then it will give 0. Different means 1. So 1 0 0. So we will take this value 0. Right. Next we will perform again 1. So 1 1 0 1. So again perform the mod 2 division. Okay. So 1 0 1. So next bit, that is 0. Okay. So again mod 2 division 1 1 0 1. So here the difference, right? So 1 1 1. The next 0. 1 0. Okay. So again ones. So 1 1 0 1. Okay. So it will give 1 1 and 0 1 1. So last one 0. Okay. So now 0. So 1 1 0 1 0 means zeros, all zeros. So if you perform XOR operation here, so different bits 1 1 0 and the last 0 we are taking. Okay. So again 1 1 0 1 once. 1 1 0 1. If you perform the XOR operation, then it will give the remainder 1, right? 0 0 0 1. So 1 is the remainder for the given data. So this remainder will be added as a redundant bit for the given message 1 0 0 1 5 0. So it will be added as a redundant bit at the sender side, and it will be transferred to the receiver side. Okay. So now let us see what will be performed at the receiver side. At the receiver side, so we are along with the message, the redundant bit 001 is transferred to the receiver. At the receiver side, it will again perform the XOR operation of the given generated polynomial with the message. So now 1101 once, 1101. Okay, so it is 0 and 1 0 0. Okay, and 0. So next ones 1 1 0 1. So different, right? 1 0 1. Okay, so this one is taken, the next 0 we will take 0. So next 1 1 0 1 once, 1 1 0 1. Okay, different 1 1 1. So next 0 once, 1 1 0 1. So again perform the XOR operation. So 0 1 1. So next 0 we will take. Okay. So 0 1 1 0 So 1101 zeros. So it will give all zeros. So if we perform the XOR operation, so 110. Okay. So last one we will take, last one. So 1101 ones, 1101. So now it will give the remainder as all zeros. So that means the data transferred is not having any errors and it is received successfully. Okay. So this is how the CRC will be performed. So next one is the checksum. So checksum means, so we are going to use the ones complement arithmetic. So to find the checksum of the given message, so we are using the ones complement arithmetic that represent unsigned numbers between 0 and 2 power n minus 1. So here at the sender side, so we are going to perform the sum of all the data here. So this is the message that we want to transfer, and we are performing the sum of the numbers in the message. So the sum is 36. So now we are going to apply wrapping of the sum. Okay, how do we perform the wrapping means? So here, so when converting the sum into binary format, that is 100100. So now in order to perform the wrapping, so we are going to take the leftmost 2 bits and add the leftmost 2 bits to the given message. So now it will give 0110 as the wrapped sum, that is 6. So now in order to find the checksum, we are going to perform the ones complement arithmetic on the unsigned numbers. So to know the checksum, so we are going to apply the ones complement. So ones complement means, so we are going to make 0 as 1 and 1 as 0. So if you apply the ones complement, then we will find the checksum of the given message, that is 1001. Okay, so this message is transferred along with the original data to the receiver. So if there is any change of data in the original data, then it will check whether the data received is correct or not by calculating the checksum. Okay, so at the receiver side, it will receive the original message along with the checksum. So now it will detect whether there is any error or not in the given message. Okay, so it will perform the sum of the total data along with the checksum. The checksum is 9. So it will perform the sum of the original data with the checksum. So now we get the sum as 45. So here, if you apply the wrapping and if you find the checksum, the result must be 0. So if the result is 0, then the transferred data is error free. Suppose if the checksum is not 0, then it is having certain error in the message, in the delivered message. So we are going to perform the sum of the original data along with the checksum, that is the 9, which is transferred from the sender. So now we will get the 45 as the sum. So now again we will perform the wrapping of the given sum. So wrapping means we are taking the leftmost 2 bits and performing the sum of the remaining binary bits. So now it will give 4 ones, that is 15 as the wrapped sum. So in order to perform the checksum, we need to apply the ones complement on the wrapped sum. So if you apply the ones complement on the wrapped sum, it will give all zeros. So that means the message received is error free. There is no error in the given message. So in this manner we will perform the different types of the error detection mechanisms. And remember one thing, that we are using these mechanisms only to find whether there is any error or not. Thanks for watching my video.